Hi students, hope everyone is fine and safe. It gives me immense pleasure to welcome you all to my new video, and today's video is about another important topic in electrical and electronics engineering subject. We're going to see what is active and passive components, and we're going to see basics about resistor series and parallel conversion and source transformations. Right, all these are very basic concepts, so you have to just understand what is active and passive components, what are the different conversions that can be used in solving any particular circuits. That is what we're going to see in this particular video. Right, to start with, we will start what is meant by active and passive components. You will have lot of definitions for active and passive components, but understand one particular thing, my dear students. Active and passive components, whenever any particular component is capable of uh, providing energy, to an electrical circuit or a component for an infinite time duration, then that particular component is called as active. I repeat that again. If any particular component is capable of supplying energy to the circuit, supplying energy for an infinite time duration, then that particular component is called as active component. Right, we can also say in different way, that is, if any component that can able to provide an average power, right, then for an infinite time duration, then that is called as active component. And whereas passive component will not be able to supply energy for an infinite time duration or a power for an infinite time duration, that is called as passive component. That is, any component that can be able to amplify, rectify, or convert an electrical energy, all those components are called as active components. Whereas passive components, it can only receive the energy, where it will dissipate or it will store the energy. Then those components are passive components. Have this as your basics about active and passive components so that you can easily understand, right? So whatever components which we use in electronic circuits, electrical circuits, you can classify that into active and passive components, right? As I said, active components are capable of providing average power, right? Or it provides energy for infinite time duration. And also we can say that uh, those components which requires an external power source to operate, that are called as active components. You can see they can produce energy in the form of voltage, current, or can amplify, rectify, or convert the electrical energy. The active components includes integrated circuits, voltage and current sources, transistors which amplify the electrical signals. Whichever components is capable of amplifying it, rectifying it, all these things are called as active components. Whereas passive components, it will not provide any energy, right, or it will not supply power for an infinite time duration, and it does not require external power source to operate, right? They can store or maintain the energy in the form of voltage or current. They will receive the energy, that is, they will consume it, right, and they will store it. And these components are resistors, transformers, inductors, and capacitors, right? So this is meant by passive component, right? You have to understand the difference between active and passive component. As I said, it's an electronic component which supplies energy to the circuits. All these are active components: voltage sources, current sources, generators, all the transistors, diodes. Diodes, when it comes to diodes, you have to understand Zener diode, photodiodes, Schottky diodes, and LEDs are called as active components, whereas there are passive diodes as well, whereas the common p-n junction diode is considered as the passive component. That's because whenever a diode exhibit negative resistance, then that diode can be called as active component, right? And whenever it is a normal passive component, that is, if just allows the energy in one direction, that is, if you take p-n junction diode, the wave characteristic will be like this, right? So then that will be called as a passive component, right? Only for diode. And when it comes to active components, we have different components. As I said, voltage sources, it is an example of an active component, where the current leads from a positive terminal to a positive terminal of the voltage source. Energy is being supplied to the circuit. So whenever an energy is being supplied, then that is called as an active component, correct? Even battery is called as an active component. And about current source supplied to a circuit by an ideal current source is independent of circuit voltage, right? And it controls the flow of charge in a particular circuit. That is why it is called as active component. Whereas transistor I have already said in previous video, transistor is used to amplify a signal, right? When it amplifies a signal, it gives power to that particular signal. Then exactly it is an active component, right? Whereas passive component, it will just only receive the energy. It will either absorb or dissipate or store the energy. Storing can be in the form of electrical field or magnetic field, right? And when we say passive, they do not provide any gain, and passive components cannot amplify, oscillate, or generate an electrical signal, right? And you can also say in another form, any active component, it will provide power gain to the circuit or a component. There will be a power gain in active component, whereas there will not be any power gain in passive components, right? And when we say passive components, it's about resistors, inductors, capacitors, and transformers, right? And when it comes to resistor, resistor is something which provides resistance to the flow of electrons, which oppose the flow of electrons. It cannot deliver any energy to the circuits, right? And it can only receive the energy, and it dissipates in the form of heat, and that is why it is called as passive component. And when it comes to inductor we represent inductor like this, whereas resistor we represent like this. When it comes to inductor is a passive element where it stores the energy in the form of a magnetic field, right? It absorbs and deliver the capacity of an inductor is limited, right? That is the nature of delivering the energy for an inductor is limited, and also it is very transient in nature. It changes accordingly, right? And it only receives the energy and stores the energy, right? And that is why inductor is called as passive electrical component. When it comes to passive components, capacitor also a passive component, right? A capacitor, why it called as capacitor? Once again, similar to inductor, what it will do is it will store the energy in the form of an electrical field here, whereas an inductor it will store in the form of a magnetic field, right? Even here, the energy which is supplied by the capacitor is limited and transient, right? And that is why it is called as passive component. As I said in previous explanation about active component, any component which is providing energy or power for an infinite time duration, that is called as an active component, right? So when it comes to transformer, right, you got to understand transformer is a passive component, right? You would have studied what is the function of transformer. It just transforms the electrical energy from one circuit to the other, from two or more circuits, right? And you would have come across a step down transformer, step up transformer. Don't get confused. Step up transformer with amplifier, right? Step up transformer, what it will do is it will step up the voltage, right? But at the same time, it will decrease the current. That is why transformer is considered as passive component. It's because when it comes to primary cycle, say for example, this is primary side and this is secondary side, right? Whatever may be, there is voltage increase or voltage decrease, the power, that is the summation of the product of voltage and the current, right, in the primary side and the secondary side will be same. That is the power in the primary side and the secondary side will be same, even if it is step up voltage or step down voltage, whatever may be. That is why it is considered as passive component, whereas transistor is considered as an active component. That's because it increases the power. There will be a power gain, right? That is why it is called as active component. You can see when transformers step up, right, from voltage, power, and energy remains the same on primary and secondary side. As energy is not being actually amplified, a transformer is classified as passive component. Whereas in amplifier, it gets amplified, it gets boosted, right? That is why it is an active component, right? So you can see these are the active components: transistor, diodes, LED, photodiode, IC, operational amplifier, segment display, battery. Whereas in passive component, resistor, LDR, thermistor, capacitor, inductor, switch, variable resistor, transformer, all these things will just absorb the energy and dissipate it, right? Whereas here it will amplify, it will generate, or it will rectify. All those things can be done in active components, right? So this is about active and passive components. And now we'll see some basic uh, formulas and basic conversions here. We would have come across Ohm's law. Ohm's law is something the product of that is V is equal to IR, which is the voltage across a conductor is directly proportional to the current flowing it, irrespective of the physical condition, right? The voltage is directly proportional to the current, irrespective of the conditions, right? It can be a temperature or any physical conditions. And that is what we mentioned as V is equal to IR. And this is very, very important formula where you can also rewrite it as I is equal to V by R or R is equal to V by I. And resistance, I've already explained the resistance is uh, something opposes the flow of electrons, right? Resistor is the one which resists the flow of electrons, and its unit is ohm. When it comes to power, you have to understand what is the difference between power and electrical energy. Power is termed as a work done in a given amount of time, right? That is the product of voltage and current. That is called as power, right? We can also rewrite it as I square R or V square by R, right? Whereas electrical energy is the electrical power consumed, right? That is generally referred as electrical energy, right? What amount of electrical power that is consumed, that is called as electrical energy. Whereas electrical power is the work done in a given amount of time. Whereas E is equal to P into T, right? That is the amount of power that is transmitted into time, that is transferred, right? In an amount of time, that is called as energy. Whereas electrical power is the work done at a given time. All these are very basic informations, right? And now you see different symbols about DC and AC circuits. You can see the voltage source, it is be represented like this, right? It can be like minus plus here, or in AC circuits it will be represented like this, a circle along with an representing the alternate current sine wave, right? And then the current source will be represented like this, both in AC and as well as DC. Resistor, you know the symbol, and you know the inductor symbol, and you know the capacitor symbol, right? And coming to different conversions, the very important, uh, very basic information in solving the circuits is series and parallel resistor combinations. Okay, so when it comes to resistance, if you take this particular circuit, you can see all these resistors are connected in series with each other. That is R1, R2, and R3. So here RT will be just the addition of R1 plus R2 plus R3, R2 and R3, right? So all these things we can call it as RT, right? Say for example, if you need to find out the current here, the current in this particular circuit, then we already know that I is equal to V by R, V by R. Here the resistance R1, R2, R3, that is taken as RT here. So if you use this formula, you can able to see the current. And if you want to find out the voltage, right, after finding the current, you can able to determine the voltage. That is voltage, there will be for every resistor, there will be voltage drop, right? So you need to find out voltage across this terminal, across this, across this. So that can be able to find out V1 is equal to I into R1, whatever current which you have obtained here, right? That into R1, we will able to apply V is equal to I into R1. We can able to find out the voltage at this particular terminal. Similarly, I into R2, we can able to find out V2. Similarly, I into R3, we can able to find out V3. And this is called as voltage division rule, where the voltages get divided, where V1 is equal to I1 into R1, V2 is equal to I into R2, and V3 is equal to I into R3, right? And all these are very basic support from Ohm's law, right? V is equal to IR, right? So this formula is very, very important. And also we can write it in this way, right? For this current, I will write V by RT, right? The same thing here, I can replace, right? So this is resistance in series and voltage division rule, right? Whereas resistance in parallel, you have to, the same RT can be calculated, but here if you take this particular circuit, R1, R2, R3 is parallel. So in that case, if it is parallel, it will be calculated like this. 1 by RT is equal to 1 by R1 plus R2 and R3. And then now you can, if for example, if you need to find out I is equal to V by R, V by RT, you can use the formula, right? Similarly, if you say this two resistor, right now these two resistor, if I need to find out RT, what I can do, 1 by RT is equal to R1 plus 1 by R1 plus 1 by R2. And if you simplify this, you can use this. You can find this formula. You can directly use this formula, or you can write like this, right? And then you can find it out. R1 into R2 divided by R1 plus R2. This is how you have to solve the resistance in parallel. So if these two resistance are in parallel, you have to use this formula and you have to find out the RT, and then you can find out the I value. Clear? Right? And now, what is current division rule? What is current division rule? This is very important rule where you can see here, this is the current, this is the overall current, and this is the overall voltage. And this current getting, it's is being split here for I1 and as I2. Now the question is, we need to find out I1, right? How we need to find out? Understand one particular thing. For finding out any particular current in one particular branch, you have to multiply that the overall current with the opposite resistance divided by the total resistance. So you see here, I need to find out I1. So what I'm going to do is I'm going to multiply current, right, with the opposite resistance. With opposite resistances R2 here. R2 divided by R1 plus R2. Correct. Similarly, if I need to find out I2, I2 is nothing but I into the opposite current is R1, resistance is R1. So R1 divided by R1 plus R2. All these are very basic concepts, very important formulas, right? And then series and parallel circuit. How to convert a series and parallel circuit, right? So if you, I need to find out RT here for this particular circuit. If I need to find out RT, or I need to find out I, now what I have to do, you can see here there is one resistor, right, which is in series with this parallel resistors. So now these two are parallel. So first what I have to do, I have to convert this resistor, right? I need to find out the parallel resistors first, right? And then I have to add that resistor with this R1. That is what we have done, right? So what is RP here? RP, you know the formula, that is equal to R2 into R3 divided by R2 plus R3. So now I can find out the RP. You can use any terms, RP, RC, whatever you want, right? So now these two resistors has become as RP. Now these two resistances series. So how can I write? So RT will be R1 plus RP. So I can able to find out RT. Now we have only one voltage and one RT and I. So how can I find out I? I is equal to V divided by RT. This is how you have to simplify any series parallel circuits, right? And coming to internal sources, when it comes to internal sources, you have voltage source and current source, right? So both this current source and voltage source will have some internal resistance. So if you see voltage source, this voltage source will have small value of resistance, right? It has resistance which is very small. So it is mentioned that this is voltage source, right? And it will have a series with the resistance will be in series with this particular voltage source. When it comes to current source, the resistance value will be high, right? So this current source resistance will be parallel. Remember this, right? And you can also convert from a voltage source to current source. For example, whenever you want to convert this voltage source into current source, what I have to do is I have to change it to a current source, and I have to make this series resistance into a parallel resistance. Similarly, if you have a current source here, current source will always have a parallel resistance. And when it comes to voltage source, I can put it as voltage source and I convert this parallel resistance into a series here, right? This is how source transformation will take place, right? So this source transformation and resistor series conversions, and as well as series parallel simplifications, right? All those are very, very important topics for simplifying the electric circuits, right? So today, what we have seen is we have seen basics about active and passive components. What are the different active and passive components? And we have seen basic terminologies and basic conversions for simplifying the electric circuits, right? I believe this video will be very useful for you. Thank you, my dear students.